Example number 2, evaluating numerical expressions involving factorial notation. So the instructions are evaluate the following. 10 factorial. We know that from our example is just going to be 10 times 11. No, wrong way. Remember, it's descending order. 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. You might be thinking, are you serious? Do I actually need to write all those things down? No, you do not. So I have here up on my screen my TA83, and let me just show you. This is where we need to get to. We need to get to that exclamation mark there. But I'm going to clear it so that we can go there. So I go math. Hello. Yeah, math. And I scroll over to, or arrow over to PRB. That stands for probability. So under this is where you're going to find a whole bunch of different commands that are dealing with the next two units, the counting methods unit and the probability unit. So I can either arrow down to 4 or I can type in 4, and that will give us our exclamation mark. Now, you'll notice if I say something like a negative number, so I'm going to go clear. So if I say -9 and then I go math, actually I'm gonna do something different. I'm going to put this in brackets. Let's see what happens when we put -9 factorial. Enter. You'll notice that we can't do it. Let's think about it. If I were to say descending numbers, if I were to say -4 factorial, that means consecutive descending numbers. So that means that it's going to be -4 times -5 times -6 times -7, all the way down to -infinity. There's no bound on it, okay? There's no stopping it. Because it descends down to -infinity. Another reason why it doesn't work is because we're talking about just natural numbers. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. So it doesn't include 0, and it does not include negative numbers. So that's just a fun little fact. But say you actually want to finish this question that we started, 2 minutes ago. I'm going to say 10, and then I'm going to go math, go over to probability, type in 4 to identify or to get that exclamation mark, and enter. Look at that. That is a huge number. 3,628,800. Whew! That's big. All right, so let's look at this one right here. I'm going to do it the long way first, so please stick with me. But then I'm going to show you a shorter way. I'm just zooming in on it so I can give myself a little bit more space. So this 12 factorial literally means 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 3 times 2 times 1. Oy, oy. And then on the bottom we have, actually I'm just going to highlight it just so that we know what we're looking at. So 12 factorial is the same as this. 9 factorial is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So our 9 factorial is this. And our 3 factorial, I'm just going to anticipate writing there, is going to be times 3 times 2 times 1. So I'm going to use a different color. I'm going to say use red, and let's cancel all that we can. I can cancel the 9 with a 9, 8, 8, 7, 7, 6, 6, 5, 5, 4, 4, 3, 3, 2, 2, 1, 1. There are other things that I can cancel at this time too. I can say that 2 goes into itself 1 time, and 2 goes into 10 5 times. I can say 3 goes into itself 1 time, and 3 goes into 12. 3 goes into 12 4 times. So actually, what I am left with here is just 5 times 11 times 4. I really should have said 4 times 11 times 5, but it's the same thing, tomato, tomato. And what's left on the bottom? We've canceled out everything, so it's just over 1. 5 times 11 times 4 is 220. Done. There is an easier way though, folks. We don't have to write out everything here. What I can do is I can just expand 12 factorial until I have a helpful factorial that I can cancel with at the bottom. So if I'm to write this out again, so 12 factorial over 9 factorial times 3 factorial, I would say 12 times 11 times 10 times 9. But really, folks, 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, that is just 9 factorial. So 12 times 11 times 10 times 9 factorial is actually 12 factorial. And then what I can do is I can just cancel the 9 factorial with the 9 factorial. Now we have something a little bit easier and a few less steps. So we have 12 times 11 times 10. But I can expand this 3 factorial, so 3 times 2 times 1, and look at that. 2 goes into 10 5 times. 3 goes into 12 4 times. So then 4 times 11 times 5 divided by 1. Bingo bango, we get the exact same answer. Exact same answer with less work. And when I say work, it just means that you understand that 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 is 9 factorial, which is a helpful factorial to have to cancel with the 9 factorial in the bottom.